thank you guys for joining me while I'm closing out the day. This talk, why predicting fraud, sports, and Bitcoin look alike. I'm really curious why you guys are all here and want to see this. If we're like-minded and you're trying to win in a crazy market, or if you're just trying to do your day job, hopefully you guys could get something interesting out of this. So what is this talk about, right? So like I said, are you trying to get rich, or are you trying to, learn some interesting engineering and data science techniques? Today, I plan on walking us through the machine learning lifecycle, broken it up into 3 phases. So phase 1 is the business and data understanding, and then 2 and 3 are model development and model operations. And so we're going to walk through step by step and just talk about these different domains, what's similar and what's alike. And yeah, why am I giving this talk, and what do I want you to take away? Like, I'm not here selling anything or anything like that. For me, I'm a hobbyist, and I'm also a professional. And one of the things that I've really gained a lot out of my career and free time is I've learned that if I'm working on side projects and side hustles that can help me with my main hustle, it really pays off. And so just thought it'd be cool to share some of that and maybe inspire some of you guys to wake up at 5 a.m. and work on something crazy. But in addition to that, there are a couple takeaways I did want to give you guys today for this presentation. So, yes, we're going to walk through some of the examples and the challenges of delivering ML models at various scales. We're going to pick up some tricks and tips in the real-time space. And then we're going to talk about how you could borrow some ideas from one domain and bring them to another. So, I'm losing my voice. And why should you trust me with all this crazy advice? I've been in this space for over a decade. Started off at NCR, was doing a lot in the computer vision space, did a lot of graduate research at Tech, go Jackets, in machine learning, et cetera. And then I've just done a lot since then. And today I'm at Feature Space, which was just acquired by Visa and specializing in financial fraud. So let's get started. So phase 1. So what we're going to talk about here is the business objective, ML objective, data, feasibility, and then how do you know when you're ready to leave, right? You got to do a POC to get out of this phase. So when we think about these 3 domains, when we think about what business problem are we solving, so in the fraudulent space, we're going to be talking about payments here, right? So we're going to be talking about fighting payments crime. In the Bitcoin space, the problem that we're trying to solve, a lot of people want to solve a lot of problems with Bitcoin. For the scope of this presentation, we're going to talk about beating the market. And then if you're sports betting, there's a lot of reasons why you might be sports betting. We're going to say the business problem you're trying to solve there is thrill seeking. So how do you translate that business problem to an ML problem, right? So in the fraud space, is this transaction fraud? In the Bitcoin space, again, if you want to beat the market, there's a lot of options you have there on how you want to frame this, but for this presentation, is Bitcoin going up or down? And then in sports betting, do I have an edge? Should I make this bet, right? What data is required across these 3 different domains? There's some similarities and some differences, but in the payments space, you want payments data, right? You want to know about the person that is, or the entity that is making that transaction. You want to know about the merchant, what's trending, the categories, et cetera. And you might even want to know if there's some region-specific things happening that haven't historically happened that could be a good indicator of fraud. In the Bitcoin space, I'll boil it down. You want to know about the economics. You want to know about CPI. You want to know about all these different economic indicators. You want to know about markets, not just Ethereum and Dogecoin. You probably want to know about Forex and ETFs and all the different markets. And then we all know news is huge here too, right? Is the U.S. going to create digital, Bitcoin reserves, et cetera. In the sports space, the data and what you're learning, the common theme here is the data is very domain specific depending on the domain that you're in. So in the sports space, what's unique here is in Bitcoin, you are going against a market and it's an open market. Any trader can enter that market, big or small. In the sports betting space, unless you're doing like daily fantasy, you're going against casino, right? And so you want to know what are the odds at various casinos if you're going to make a bet. You want to know about sports fundamental data. You want to know, is someone's batting average historically been good against this pitcher? You want to know, sports news, and it might not actually be the sports part of the news. Like, is someone getting divorced, or were people out late getting in trouble the night before the game, right? And then finally, when you're in this phase, you want to be able to ensure you're assessing the feasibility of how likely is it that you could solve this problem? Where are you measuring yourself so you could then determine if you want to go to that next step, right? So in the fraud and financial space, we'll say, can you beat the incumbent? Can you beat the product that already exists today? Can you beat that analytics solution? In the Bitcoin space, can you beat everyone else, right? This is a 24/7, by 365 market, right? It's one of the most competitive markets in the world. Can you beat everyone else? And in the sports betting space, can you beat Vegas's algorithms and what we also call VIG in this space, which is basically that's what the casino's getting every time you make a bet, right? And so if you're going to try to be profitable, you need to ensure that you're doing enough to not just break even, but to make more than that entry fee. And then how do you know you're ready to move to the next phase once you've looked at that feasibility and once you've started to build out a POC? This is very similar across all three domains, right? And I would call this, everyone doesn't use this terminology, but I would say a successful back test and a successful forward test. So you have your historic data, you've built something in isolation offline, you see that it performs well. Guess what? If you've been working on that for a while, not just did your model or your features likely overfit, but you may have overfit because you've been staring at the same thing for a certain period of time. So it's super important to do a forward test on unseen data that you haven't been tuning anything on, right? That wraps up phase one. Phase two is around model development. And in this section, there's a lot we could talk about. I just wanted to call out a couple key aspects of data engineering, of model engineering, and model evaluation, because this is like a 20-minute talk. So for data engineering, when we're thinking about the fraud space, there's real-time trade-offs, right? So in my world, I've got to be under like 30 milliseconds, right? So like that's API call from the payment source, to wherever we're computing, right, back, right? So if I'm computing any data engineering, any feature engineering, et cetera, I've really got to take into account what are those real-time trade-offs. There was a great talk earlier today about fraud on GitHub, and he talked about how you need to look at something from 5 seconds ago. We want to be able to do that, but look at something from maybe even months ago instantly as well too, right? Second problem here is how do you get your labels, right? Like how do you know something actually was fraud? That's, who's going to tell you, right? And then in this space, anomalies that's the name of the business, right? Like fraud isn't happening all of the time. How do you deal with your data balance when you have anomalies? And the amount of labels that you actually do have, is that representative of how much fraud there is out there? Probably not. And then last but not least, in this data engineering space, you can't deploy all the time in a highly governed space in the payments sector. So what can you do as you're computing your features? When you think about normalization and standardization, how can you deploy features in a way where you don't need to touch them for a long time, right? That's a long time in machine learning years. Okay, Bitcoin. What's really key here is your labeling strategy. If you want to predict when something's going to go up or down, what's your time horizon? Do you care about the next hour? Do you care about the next day? Do you care about the next year? That's going to heavily impact, how great your indicators are and your feature selection, et cetera. And then finally, there's so many financial libraries out here in financial engineering and quantitative finance. It's so easy to just say, let me generate like 10,000 features, feed it into a deep learning model. What's going to happen there is you're going to notice that you really have to select and wind down. And when you have a really big search like that, it's really easy to overfit on the features that you've selected. And so my advice here would be, how could you do something in an intuitive way that you're not making it overly complicated and it's still providing value? For sports betting, what's unique here, if we're talking about NFL football, is the sample size, right? There's 16, 17 games in the regular season. If you wanted to bet on a game for a team, right, like there's not a lot of history there, right? If you were talking about predicting Bitcoin for the next hour, there's so many hours in a year, right? So it's just much different scales of data, et cetera. And then finally, you want to take into account what's called expected value when you're doing your data labeling and your feature engineering. Expected value, for those of you that are unfamiliar, is you place a bet, all these bets over time on average, what's the expected value that you would have in earning, like if you won 51% of the time and each time was $100, your expected value would be like $1 or $2, right? All right, model engineering. So I wanted to talk about transfer learning here. And transfer learning can have many different meanings in the machine learning context. The way I want to think about it here is how I've thought about it in these three different domains. So particularly in the financial and fraud space, does one model rule them all, right? Can I deploy the same model to predict fraud in Asia and in North America? Can I predict the same model use the same model in the state of Georgia versus Canada, right? So how do you determine what data you could share across regions and merchants and banks and people? And how do you determine which data you shouldn't be sharing? And how do you determine if you could learn something from another area that you haven't used in your universe that you're building for, right? In the Bitcoin space, how stale can a model be? So if you think about you're trying to predict the next hour, right, you might need to have a training pipeline where you're retraining a model. You might not be able to have your model from 2023 in 2025 if you're predicting the next hour, right? So how stale could this model be? How stale could the data be that you use? And then what's the cost of that training pipeline? Is that cost exceeding your profits? If you're like me in my first couple of years, the answer is probably yes. And then from a sports betting perspective, we talk about data size, and what I think about from a transfer learning perspective there is if I'm predicting, the Atlanta Falcons for 2025, do I want to use insights from other teams and other years, or do I want to purely build a model for just the Atlanta Falcons, right? So there's trade-offs in specializing and sharing, et cetera. And then finally, you're evaluating your model. You want to determine that you're ready to deploy and put this in production. There's obviously different metrics that you care about in each of these domains. In the fraud space, to boil the ocean, your catch rate versus your disruption rate, right? Like, are you catching enough fraud to justify stopping people, from completing their transaction, right? In the Bitcoin and sports betting space, this might be coming from a hobbyist perspective, but I'd want to get that model out there as soon as possible, paper trading. And if I'm successfully paper trading and then I could then put real money into it, the way I'm making that decision is I'm looking at completely unseen data and seeing if the results of that have matched the previous POC that I've done, or am I seeing a lot of drift or inconsistencies? And depending on your time horizon, it could take a lot of time or a little bit of time, right? So, Phase 3, model operations. So here we're going to talk about model deployment and monitoring and maintenance. So from a model deployment perspective, don't have enough time today to talk about all the different technology choices we could make, but just wanted to call out some of the considerations from an architecture perspective and just some of the things that I've observed. So one, in the fraud space, I briefly touched on governance when you're deploying into a space that has different compliance certifications, a lot of sensitive data, et cetera. One of the things that you really need to think about is this analytical change that I'm pushing to production creating bias? Am I predicting fraud for certain demographics or for certain socioeconomic groups at a higher rate than I am for others, right? Are we okay with that as a society, right? Or are we okay with that from a certification and compliance perspective? The next area is, do your data feeds have differences. When you're looking at your historic data that you've been looking at offline versus this data that you might be getting in the financial space, are you going to be surprised by the data that you're receiving? Maybe. And then finally, are you going to be pushing this into the cloud? Are you going to be pushing this into a secure on-prem data center? What is the topology? And that's going to heavily influence a lot of the technologies that you're choosing when you're deploying this model. In the Bitcoin and sports betting space, I would say there's a lot of similarities here if you're a hobbyist. One, this is a fast-moving, real-time space. So I've experienced firsthand many times discrepancies between the historic data that I've been using and the real-time data. And then additionally, when you think about engineering and architecture, sometimes you want to make something really hard because you want to solve a really hard problem, but it's best to take a step back and say, from a non-functional requirements perspective, how much do you really need here, right? How much scale do you really need? How much resiliency do you really need? If you're going to do one of these projects, are you okay with running this on an old laptop in your apartment? Or do you need to bust out your wallet and go to the cloud, right? So there's a lot of decisions based off of your non-functional requirements that you should be intentional about. And then when you're monitoring and the maintenance required here, there's a lot of similarities here. A key difference in the fraud space is that label collection, right? So when am I going to know if that transaction was fraud? When am I going to get that feedback, and how could I use that to retrain, et cetera? But obviously a key thing here is your drift detection. Are your distributions changing, and has latency changed as you've deployed this in a production, et cetera, as well too. So those are the three phases. I'm going to wrap up with just some consolidated advice here. So the first thing that I would call out is wisdom of the experts. So if you want to compete in this space, and you got to realize there's a lot of people that have been in the space for a long time, and there might be one or a few experts that it would be amazing if you could understand what their analysis was, right? And then if you could build on top of that, right? And so this was something that I discovered very early in my career, was if I could get expert data, then that was a great way for me to differentiate. The second area, you got to find your edge. We all know in this space, with a lot of competition, if you don't find your edge, you can't compete. Here, domain expertise really does pay off. The more that you understand about your domain, the more that's going to give you, ideas and intuition around the features and analytics that you could build around that. And I would highly recommend not knowing, if you're going to do something in your space and you don't know the domain, don't just mess around with sklearn. And then balance complexity and time to validate. So this is coming from an innovation perspective. You're best off when you could iterate frequently. If it takes you a year to do your POC, something's probably wrong there. How can you reduce the complexity and scope to where you could incrementally see the fruits of your labor, and then take that feedback and iterate. And then last, pick a problem that you're curious about. We've all worked on toy data sets that have no meaning to us, and you're probably not going to wake up at 5 a.m. or stay up after your day job to work on something if you're not interested in it. And so I'd highly recommend to find something that you really want to find out more about. So that's what I have. I was trying to wrap it up and keep you guys, not keep you guys from the happy hour. So I think I am at time, but if you guys have any questions or want to connect with me, I'll be here. I'll be at the event tonight too. So yeah, just let me know. Thank you. Cool. We good? Are we shutting down? Yeah, if you guys have any questions, I'll take questions, but I totally understand. There's free beer, I think, soon, so. Yeah. Have you successfully built any models for Bitcoin or any research? Define success. In the Bitcoin space, No. In other spaces, it depends over what time horizon. So, like right now, things are good, but I'm still working. Oh yeah, there's a ton. I mean, when I started out, I was lucky enough at Georgia Tech in our grad school course for machine learning for trading. That course is free now, and you could find that online. Yeah, you could. I would start with something like that, and then I would say, depending on what you want to do, like the way I viewed that course was a three-legged stool of finance, data science and machine learning, and like Python and software engineering, right? So depending on what leg of the stool you want to learn about, then I would say go from there. But that's a great introduction. Awesome, yeah. So with the sports betting, so I've had a couple plays at that. So I first started off doing like daily fantasy for basketball. So for those of you that aren't familiar, that's where you could basically generate lineups every day, and you have a budget that you could pay for a player or whatever, and then you could like submit these lineups. And so the name of the game there is how many lineups can you submit, and then how different could your lineups be, right? And so when I was talking about knowing what the cost is to like retrain and all that sort of stuff, I ended up building like this crazy pipeline that was costing me more than what I was earning. I was entering like these very low, like beginner level tournaments, and then when I tried to go to the more intense ones, it was like, well, the solution I have isn't viable for that, right? Or well, I'm not winning, and I'm winning in the cheap ones, right? So that was kind of round one, and then round two over COVID, I got into so during COVID, no one was playing sports, right? People were either racing marbles and putting it on Twitch, or there was Eastern European ping pong that was really interesting. And so I built some live betting bots for Eastern European ping pong, and then it came out that everything was rigged, but it was a lot of fun, good learning. Yeah. But yeah, I've plenty of stories. If you guys want to catch up later, I could tell some more. So cool. Thank you guys.